So now that we've seen the comparison, or at least a rough comparison, I'll admit to you that that is true, a rough comparison between what a spreadsheet is and what a database is, let's talk about what exactly is a database. So a database is a collection of data, not information, just data, little snippets of transactional data that lives in what are called tables. Now, a table really does kind of look the very same way as an Excel spreadsheet, rows and columns. Um, that database and those tables are accessed not by the database itself, but by a different program entirely. So if you think about Netflix as a database, that is absolutely the case. The database would contain things like the titles of movies, the lengths of movies, the type of movies, so family, action, adventure, comedy, so on and so forth. It would contain things like, the actors' names. It would have data about the actors someplace else in another table. But none of that is Netflix, right? When you go to interact with Netflix, you don't think of all that data hanging out there in the background. You want to put in the name of a movie, and boom, we want that movie to appear. So Netflix really is a database, but what we interact with is the Netflix app, the thing it is that can use that database to find the content it is that you're looking for and display that content on the device it is that you're looking for. So a database has that one big difference over an Excel spreadsheet. Excel spreadsheets work through Excel. There's a one-to-one relationship between the the software and the data it is that we're putting into it. With a database, there could be numerous different other platforms that connect to that database and that still have the ability to access that data, but they're not actually related to each other in any real, like satisfactory way. So a database is a collection of data. It's not necessarily one application where we can collect and manage that data and display it for consumption by shareholders, people that need access to that data. So next, a database is also a very, very highly flexible way to sort and organize data. The way we do this is what is called a query. A query is essentially a question. It's a very structured question that we use to ask a database to retrieve, that's the word I'm looking for. We ask a database to retrieve the records, so the individual bits of data that have some connection to the query, the question it is that we are asking of our databases. So, for example, if I was to use one of the Rock Valley College databases, so RVC Eagle is it's not a database itself. Eagle is really just a platform. It's called InStructure. But in order for us to connect InStructure to our student information, we need a database. In that database is all sorts of data about you guys, the students. So each class we would have, so CIS 102 would represent one table in our database. So information in that table in our database would be the course name. So if you look in the upper left-hand corner in Eagle, you would get a course code. So it's something like CIS 102 H010, CIS 102 OA 030, things like that. That course code corresponds to your exact class here in Eagle and your exact class here at Rock Valley College. So each one of those tables has that little piece of information. Then we would have student names in that table as well. Student last name, student first name, student ID number. And we could go from there. We would also have, potentially, maybe we could also have other pieces of information, but really we don't need them there. But what that table allows us to do is I can say a query. So a query is just a question. I can question what students are in CIS 102 with your course code. What would happen is my platform, so Eagle, would go and run a query on our database. So that database is here internal at Rock Valley College. Those tables are looked through in a very, very highly structured way, and only the matches with our course code, CIS 102, whatever your course code is, would return as true. Now that I found a table that has that course code, I can go through and look at what students are enrolled. And I can print a query, I can print the response to my question that would match that request. Now, when I'm done, do I need to save that query necessarily? Am I going to be concerned with what students are in my CIS 102 class next time around? Maybe, but it might change. So the interesting thing about a database is nothing is stored as long as all of the data is in tables, as long as all of the data in tables is structured in a way that it can be searched quickly. I don't have to save any of my questions, any of my queries out for later on. So for example, think about this. If I was to, and I did just, I had to, it's over this shoulder right here, go retrieve another copy of our Rock Valley College logo. If I was to do a query for RVC logo, that is me going through a web portal, google.com, asking Google to go to its database, the crazy data that Google has stored in all of its databases, and I'm asking a question. Find for me all images with a name or a description that matches Rock Valley College logo. And then it returns for me a bunch of stuff. Some of that stuff is our Rock Valley College logo. Some of it's the eagle, some of it's this one. There's a bunch of different ones. Some of it is the Rapunga Vedic College. They also have RVC as their school abbreviation. As a matter of fact, there's like 12 or 13 different schools that have RVC as their abbreviation. I go through, I pick the right one, I grab the image I want, and I go away. Now, Google doesn't have a ton of vested interest in keeping that search query around, so it's gone. So that's the interesting thing about databases. When you go use one of your platforms, your applications, or services, so think about things like Threads, Instagram, TikTok, etc. Even RVC Eagle, which would be InStructure, is the platform that we're using there. When you go through and you make a query, so show me the new stuff that has accumulated in my account, none of that is stored anyplace. That all is returned to you via query in real time as you're using the app. So what it does is it goes through, it's got your interests, it's got your piece of the algorithm, it can store your information and push that through the algorithm and return for you all of the content it is that you are looking for. That happens in real time. And when you're done looking at it, all that stuff can just go away because you'll just make another new query later on and we'll populate that with all the brand new data that's coming into the system that you don't even know you're going to see anymore. So it's a little strange if you think about it. So you're telling me we have this vast storage of data and we can just ask it any sort of question and return to us an answer? Yeah, that's exactly what we do with databases. Where is stuff stored? Well, the database worries about where stuff is stored. How do I gain access to the stuff that's stored? We need another application or we need another platform to be able to do that. So when you query Google, you're not really interacting directly with the Google database. You're interacting with something that can interact with the Google database. So a web browser. If you're looking for your mail, Gmail is the application that can get access to the database. So you need something else in between, which is different than how Excel works because everything is baked right there into the application. All of the services we use are based on databases because of that rapidity, how fast it is we can put new information in and get new information out. So databases, incredibly powerful. We'll just take one more video here and talk about what to expect in the Cengage portion of this particular module here for CIS 102.